let's talk about Null, specifically how to deal with Null when it comes to your shapes.io machines. Null is one of the few basic signals, or lack of signal in this case, that can be transmitted on the wires layer in shapes.io. The other signals are a 0 or a 1, which are your Boolean options for false and true respectively, but also a shape or part of a shape and a color. Shapes and colors are treated like a 1 for all intents and purposes on pretty much any logic system inside the game. So this is really helpful to understand, but let's talk about Null. Null is actually not handled always like a 0. You would think it would be, but things like filters, for example, don't do this. If you send a Null signal to a filter, it'll flash the little wire broken symbol and do nothing, which means both of its outputs stop. This can be a problem if you have a logic system set up to adjust your outputs for when a corner or a part or a whole layer is missing and you're trying to build your shape. So you need to handle that, and generally you want to handle that by turning the null into a 0. Now, because your signal, be it a shape or a color or a 1 or that null, generally is going to transmit on the same line, you need to have an inline mechanism to either push through the appropriate signal or turn that null into a 0. So on my screen here, what we have is my designed example of how to do this. Now I'm sure other people have built the same thing very similarly, and in fact, in a few minutes here, I will show you another user's built version of it as well, which is also very elegant, even a little bit smaller than my version, which is also very useful. So let's look at how this works. These are 4 examples of signals coming through. Here we're getting a whole shape, here a null, here a constant 1, here a color, just for examples. And on the other side here we have the output example. So constant shape comes in, constant shape comes out. Null comes in, this is the symbol for null here, a 0 comes out. 1 comes in, 1 comes out, color comes in, color comes out. It's very straightforward. All right, let's look at the details. So in this example here, the input wire, in this case a constant shape, for 1 goes to this first transistor. This transistor then sends that signal on through because its side input is truthy, or a 1 in this case. The way transistors work, and this is important to understand in general, is they will always send the signal through if the side input says to be on. In other words, it's truthy. So this is your input signal, this is your on-off signal, and then it outputs whatever the input signal is. A 1 or a truthy signal says on, a 0 or a null will tell a transistor to be off and thus stop the output. So in this case, the wire comes in, goes to the transistor, but it also turns here and goes to this first NOT gate. This NOT gate turns it, inverts it, turns it from a positive to a negative, or negative to positive, 1 to 0, 0 to 1. And in this case, because it's coming in truthy, it outputs an untruthy 0. This 0 comes over here to a second transistor, which tells this transistor to be off, so nothing is actually being output from this transistor. So this wire is getting a signal from this transistor here, the first one. This same signal is also passed through to another NOT gate, which then tells this transistor to be on. So if truthy comes in here, NOT, we get truthy here. So in this way, it's passed directly through. Now the inverse case, let's say a null is coming through here. NOT gates treat nulls as 0s, so it inverts into a 1. So the pass through here is a null. This transistor is off because NOT of a null is a 0. So this 0 tells this transistor to be off. At the same time, this first NOT gate turns this null into a 1, which this wire carries over to that second transistor. That tells this transistor to be on, in other words, open. And what it's feeding through is the result of this NOT gate, which is a 0. This outputs a 0. So this transistor is doing nothing. This transistor is allowing whatever's behind it come through. Whatever's behind it happens to be a 0, and therefore we're getting a 0 output ultimately. So any null or 0 will result in a 0. Any positive thing, any truthy thing, will result in that truthy thing going right through. It gets knotted twice, cut this on, this is off, it comes through. It gets knotted twice here to cut this off, which cuts this one on, and thus is allowed the 0 to go through. It's very straightforward, very quick inline example. It's only about 3 rows wide, which is pretty easy to plug into most of your wiring spots. So let's look at a different example that another user showed on the forums in Steam. So this example was shown by a user named, I believe it was Aleph, but I don't know if they developed it themselves or just found it elsewhere, I don't know. But it's also a very elegant, very small example, and works very well. So here we have a shape examiner outputting a full shape, which is considered truthy. It goes to this first transistor. So it is both the input signal and the on-off switch. So because a shape is truthy, this transistor is on, and because it's coming through the input side, it comes out as well. So this transistor is outputting that same exact shape that came through. Here you go. That signal is also passed through to this NOT gate, which then turns it from a truthy signal into an untruthy or a 0, which then tells this transistor to be off. And so this transistor does nothing right now because this one's on. So in a different scenario, when a 0 is coming in, or a null, or what have you, here this 0 tells the shape examiner to output null because there's no shape to examine. So the null comes out here, which tells this transistor to be off because it's the input signal is untruthy, therefore a transistor is off. It is then through a NOT gate, turns it into a truthy signal, a 1, which tells this transistor to be on. This transistor has a constant signal generator here, outputting a 0, which then causes the ultimate output to be a 0. So both of these cases, my example and this one, both do the same thing. The difference is in how they generate the 0 here and which angle they kind of have to work at and how much space they take up. This one is smaller in this respect. It's larger than this angle depending on how you want to lay it into your signal system, but it'll work. So real quick, let's look at an example of how I use this in my Make Anything machine. I'll just go to my first layer here. So this Anything machine takes in the entire full shape from the hub and splits off the top layer. This happens, 3 more times down below. But the very first thing I do with it is send it through a NOT checker, or a null checker or a null gate, which does its thing. And if this were null, it would output a 0. Because it's a shape, it outputs the shape. This wire then runs all the way down, in my use case, to the very end, the last merger here that makes the final shape. And this goes to the output filter. I actually have 2, so there's one down here as well. Same kind of deal. Goes to the output filter, and if a shape is coming through, it'll compare that shape post stacking to what's coming out, and if it's the same thing, great. If not, it trashes it like any filter normally does. If a null was on this layer, so if this layer was empty, it would then receive a 0, which would cause this shape, this filter, to pass any shapes coming through it into the trash can, and thus clearing out my queue of any unneeded shapes that are still stacked up while the hub was being filled up. I use this a few other places in line. I can quickly show a couple others to do various similar things. So here I'm taking in the partial shape, putting it through a NOT gate, and a null gate. And this comes through and tells this filter to kill anything lined up if it's not related to this particular partial shape. Here and here, same kind of deal. One does the whole shape, one does the partial shape. Either way, it does the appropriate filter result here or down here to tell the filters what to do with that result. So yeah, that's a null gate. It's a quick way to deal with a potential missing section of your signal, and is very, very useful, and you will need it when you look at building your Make Anything machine to deal with missing corners, missing halves or whole shapes, or missing layers entirely. So I hope that was helpful, and good luck.